geosphere is heterogeneous. It is made up of different layers. Scientists and experts classify these layers into two types: the chemical composition and the physical properties. In the chemical composition, we found three divisions: the crust, the mantle, and the core. In the geosphere, we found different materials that change in density with depth. This means that denser materials are normally found in the core, while less dense materials tend to stay near the crust. The crust is the outer and inner rocky layer of the Earth. The rocks are rich in silicate minerals, which contain oxygen and silicon. The crust also has aluminous silicate, which contain oxygen, silicon, and aluminium. There are two types of crust: the oceanic crust and the continental crust. The oceanic crust is found beneath oceans and seas, taking over about 65% of Earth's surface. On the other hand, the continental crust makes up the continents and the continental shelves. The oceanic crust is 6 kilometers thick. It is mostly made of basalt and gabbro, and its average density is about 3 grams divided centimeter cubic. The continental crust is about 30 kilometers thick. It can be 70 kilometers thick in large mountains range. It is made of granite and large masses of metamorphic and sedimentary rocks. Its average density is about 2.7 grams divided centimeter cubic, and as we can see, is less dense than the oceanic crust. The mantle is between the crust and the core. It is 2,900 kilometers thick. In the mantle, the rocks are much richer in iron and magnesium than the rocks found in the crust, and it contains less silicon and aluminium. The mantle is divided in two: the upper mantle and the lower mantle. And the final layer is the core, which is the deepest and thickest layer of the geosphere. It is about 3,500 kilometers thick, and it is made up of iron and nickel. The core is divided in two: the outer core and the inner core. On these divisions in the chemical composition of the Earth, we found three discontinuities. The first is the Mohorovsky discontinuity, and is the boundary between the crust and the mantle. The second one is the Gutenberg discontinuity, and is the boundary between the mantle and the core. And finally, the third discontinuity is the Leham, and is a boundary between the outer core and the inner core. Now we come back to the start. Referring to the physical properties, the study of the propagation of seismic waves through the geosphere, which depends on the mechanical properties of the materials, has revealed the existence of 5 concentric layers. The lithosphere is the outer shell of the geosphere and consists of the crust and the uppermost mantle. It is 100 kilometers thick. At some point, it can be 300 kilometers thick. It is made up of solid, rigid, and brittle materials. And finally, the lithosphere can be oceanic or continental, based on the type of crust that it has. The xenosphere. The xenosphere consists of materials only from the mantle. It is about 600 kilometers thick. In this layer, the rocks are found in a solid but plastic state. Therefore, the materials can deform and flow very slowly. The xenosphere is solid, but is more plastic than the lithosphere. The mesosphere. The mesosphere, or lower mantle, is also made of materials only from the mantle. It is about 2,200 kilometers thick and is located between the xenosphere and the core. The high pressure in this layer keeps the rocks in the solid state. Also, they are more rigid than in the xenosphere, but they are still plastic and they can deform. The outer core. The outer core that is located between the mesosphere and the inner core is about 2,200 kilometers thick. This layer is semi-liquid or liquid, despite the fact that it is under a greater pressure than the mesosphere. This is because the melting points of the materials, in this case nickel and iron in the core, are lower than those in the mesosphere. The inner core. The inner core is the deepest layer on Earth. It is about 1,300 kilometers thick. It is made up of metal, and its components, the iron and the nickel, remain in the solid state. It has a lot of pressure and a temperature of 5,400 degrees. This is the structure and the characteristics of our geosphere.